All right, so welcome everyone. And as I stated earlier, that we're going to be basically talking about, again, the main ideas starting from the mean, which we discussed last time, median, mode, mean, median, mode, 5-number summary, empirical rule, and z-score. Okay, out of these, we already did take care of the mean, which is the average, and we calculated by adding all the values as it shows on my slide of the variables in the data set and dividing by the number of observations. We find the median by finding the middle number. We find the mode by looking at which number is frequently repeating. And then we talk about 5-number summary. We did talk about the shape of the graph, skewed left, skewed right, and all that. So I am going to be thank you for letting me know, Caesar, that you're at work and actively listening. Couldn't reply. That's fine. Okay, so 5-number summary and empirical rule. Okay, we're going to be talking about that. So taking us forward, this is talking about mean again. So there were two symbols that I talked to you last time, that we use the symbol X bar when we are finding the sample mean. We use the symbol mu when we find the population mean. Population means the big group, if you remember. Okay, we have done that. Population arithmetic mean. We find the mean same way, but we use the symbol mu. Okay. X bar for the sample, mu for the population. Formula is same when you find the mean. And I'm shuffling through the slides because I'm going to take you down to where we need to be. We have done the median already. Okay. So median, we put the data in the small to large order, ascending order, and then we find the middle number. If there are two numbers in the middle, we find the average of that. That whole information is repeatedly written here in the PowerPoint again. Okay, so I am taking you down to this one that we also discussed last time and shared last time. This is important because this comes often in the exams and students sometimes confuse it. Skewed left, skewed right, and symmetric. For skewed left, you can tell by looking at the answer of the mean. Mean is substantially smaller than the median. Skewed right, mean is substantially larger than the median. For symmetric, mean is roughly equal to the median. And here are the pictures shown. If the picture is like this is called skewed left. If picture is like this, that's called skewed right. For skewed right, mean is greater than the median. For skewed left, mean is less than the median. For symmetric, mean is equal to the median. So this is an important slide, I would say, in your slide deck, and I will ask you to mark it important. That slide number 19 in your slide deck is very important for you to keep in mind the shapes of your graphs and curves, skewed left, skewed right, and symmetric. The symmetric, which we are calling here, is also called bell shape when we will do the empirical rule in a couple minutes, okay? So now I'm going to take us forward to the next thing, which we are planned to do today, the z-score and empirical rule. So I'm going to skip a couple more slides because we already did the mode and all that. So we don't need to repeat that. We did the range also. We did the standard deviation also. We did standard deviation with the calculator. Okay. And I am going to take you down to now the empirical rule. So shuffling a couple slides. And also before going to empirical rule, I want to stop here for a second on slide number 53. And this slide is talking about the variance. This also comes as a question sometime in the exam. The variance of a variable is the square of standard deviation. You were shown yesterday how to find the standard deviation. If you have forgotten, you can ask me. We used TI-84 to calculate the standard deviation. Whatever answer we find for standard deviation, if we square it, you will get the variance of that. So variance is the square of the standard deviation. That's the goal of sharing this slide right here. Now going forward with you. The empirical rule. This is where I asked you to read the book page yesterday, and I hope that you might have read ahead of me. So this slide, I'm going to start sharing from. What is empirical rule? Empirical rule is a distribution. It's roughly bell-shaped. Now I'm going to show you the picture also in a couple of minutes that how bell shape looks like. But the main ideas that you will need to keep in mind, the first one is approximately 68% of the data will lie within one standard deviation of the mean. That is approximately 68% of the data lie between mu means mean, minus one standard deviation, and mu plus one standard deviation, one to the right and one to the left. 95% of the data will lie within two standard deviations of the mean. That is approximately 95% within mu minus 2 to the left side of the graph and mu plus 2 to the right side of the graph. You will make more sense when you see the picture. And it says in the third bullet, approximately 99.7% of the data will lie within three standard deviations of the mean. That is approximately 99.7% of the data lie between mu minus 3 sigma and mu plus 3 sigma. And here is a little note for you. We can also use the empirical rule based on sample data with X bar used in place of mu and S used in place of sigma. If you remember, X bar is for the sample, mu is for population, S standard deviation of the sample, sigma is population standard deviation. This is the picture that you will need to keep in mind always. So if you take a look on this picture, this is showing you that here is mean in the center. Right here is the mean in the center, the middle part. This type of curve, which is symmetric, is called the bell-shaped curve. And when the mean is in the center, if you go one standard deviation to the left or one standard deviation to the right, that covers 68% of the curve. And if you go two standard deviations to the left and two standard deviation to the right, that covers 95% of the curve. Okay. Then from the mean, if we go three standard deviations to the left and three standard deviations to the right, that will cover 99.7% of the data values. And after that, there's a tiny bit of tail left after the three standard deviations on both the sides of the curve. So this curve is very, 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 very important for you to know for this test as well as for this last section of the homework. So if you take a look, if this is 68%, you split it, you cut it into two pieces. The half of 68 is 34 here, 34 here. Now this was 95%. 68% was this far. Then what is the rest? 95 take away 68. 95 take away 68. You can do that roughly with your hand or on the calculator. So if you do 95 take away 68, that's going to be 27. And then if this is 27 after 68, the two sides, and this side and this side, you divide 27 by 2. The half of 27 is 13.5. That's why this is marking 13.5% here, 13.5% here, okay? Now this rule also says that 3 standard deviations cover 99.7% of the data. If that's 99.7% of the data, up to 2 standard deviations, it was 95. So if I do 99.7, take away 95, 99.7, take away 95, that would give you a difference of 4.7. That area, that is 4.7, is divided among 2 chunks or 2 pieces, right here and right here. Now, on your calculator, you may do that division, that if you cut that in half or divide 4.7 by 2, you will exactly get 2.35%. So that's empirical rule, that from your mean, from the center, your curve spans 1 standard deviation as 68% of the area, 2 standard deviation 95% of the area, and 3 standard deviation 99.7% of the area. Any question on the symbols, on the percentiles, anything that's coming up to your mind, feel free to unmute yourself or type in the chat. Before we roll on to the next slide. Couple minutes for you. All right, taking us forward. So the next thing that I am going to take forward to is an example. The following data represent the serum HDL cholesterol of 54 female patients of a family doctor. So a doctor just sitting in the office and recording the data of the cholesterol level in the women and has recorded 54 female patients. The question says, compute the population mean and standard deviation. Draw a histogram to verify the data is bell-shaped. Determine the percentage of all patients that have serum HDL within 3 standard deviations of the mean according to empirical rule. Determine the percentage of all patients that have serum HDL between 34 and 69.1 according to empirical rule. Determine the actual percentage of patients that have serum HDL between 34 and 69.1. Okay, so how to do this problem? The first thing, the first part of the problem, that is asking the population mean and standard deviation, which you can use your TA84 to calculate. So I am going to go back on the last slide and have you upload the data into your calculator. So you can all do it with the calculator and make sense of the things. So right here is the data. I am uploading into my calculator. You go ahead and upload the data into your calculator. If you have forgotten, I'm writing a little direction here that we go to stat. You press the edit choice and then enter. That will open the list for you. And you will type the data. If there is anything in the lists previously, clear that before entering the data. So I'm gonna be quiet for a couple seconds or saying the numbers, and you can go ahead, type all 54 values. And once you're done, let me know in the chat. We have the first number, 41, 48, 43, 38, 35, 37, 44, 44, 44, 62, 75, 77, 58, 82, 39, 85, 55, 54, 67, 69, 69, 70, 65, 72, 74, 74, 74, 60, 60, 60, 61, 62, 63, 64, 64, 64. Then we have 54, 54, 55, 56, 56. 56 is present 3 times. Then we have 57, 58, 59, 45, 47, 47, 48, 48, 50, 52, 52, 53. And your 54 values will be loaded to the calculator when your calculator screen says L155. That means you're on 55th line of your calculator. Okay. Let me know in the chat or unmute yourself once you're done typing your numbers. Good job, Selena, Veronica, Lou, and Selena Rodriguez. Good job, Ellie. I'm gonna also type the next direction that you will need to take care. After typing the data, you will go back to the stat button. And this time you will choose calc, one variable stat, and you're gonna press enter. When you press enter, your calculator will show all the results. You're gonna say list L1, frequency list empty, and calculate. Once you're done calculating, let me know what you find as your mean and standard deviation. Yep, the mean is 57.40 and standard deviation is 11.80. Good job, Veronica and Selena. Okay, so taking us forward. This is what you have. The mean 57.4, the standard deviation as 11.8. Now, this histogram can also be drawn with the stat plot with the calculator, and I'm going to see the directions for that as well. You can try those. On your calculator, there is a second button, second, and above the second button, there is a button called stat plot. So you go to that, and then you choose plot 1. And when you choose plot 1, say enter. And when you say enter, it will show you a couple things on the calculator. I'm gonna show you my calculator screen. Can make sense out of there that how we get to that graph. All right, so I hope my calculator screen is visible to you. So I'm gonna start from the beginning. So first thing I said that you can press this button, which is called second. Stat plot is right up above it. Second stat plot, that's what I pressed to get here. And I'm on plot 1. And I'm gonna say enter, and this screen shows up. When you're on this screen, let me know in the chat that you made this far. Good job, Ellie, Selena Martinez, Veronica, Lou. So the on is blinking. I'm going to press enter to make sure it stays on. Then there's a line which says type. And I'm going to the histogram. I'm going to highlight the histogram. You see my cursor is currently blinking on the histogram. So I'm going to say enter on that. X list is L1. I don't have any other list beside that. Let me know when you make this far. Okay, awesome. So then you're going to press the button graph. It will show you either the graph or the empty window like I have. If the window is empty, you will need to zoom your graph. Zoom 9, ninth option. Say enter, and you will have your histogram. Once you find your histogram, let me know in the chat. Any difficulty, feel free to ask. Good job, Selena Martinez. Okay, so for getting to the graph, as you look on my calculator, I was on stat. No, I was on second stat plot for graphing, and I selected plot 1. I go enter, and plot 1 is on. Then I selected the histogram because there were dot graph, line graph, histogram, and box plot and all that. I wanted to have a histogram, so I selected that. X list is L1, frequency is 1. Then I'm going to simply press this button which says graph, this one. And I will have the graph. And in case your graph doesn't show up, that means you need to zoom. Zoom button is right here. And you will do zoom stat, which is option 9. That will zoom your graph fully into the window. Waiting for your responses. Good job, Veronica. Good job, Angela. Okay, taking us back here. Here we were in the graph. This was the graph that we just saw in our calculator. Now, this is what we were learning, the empirical rule. Okay. And then we were answering the questions. The question had several parts: compute population means, standard deviation, which we did, histogram we did. Now it says determine the percentage of all patients that have serum HDL within 3 standard deviation. Now here's the answer. According to empirical rule, 3 standard deviation means 99%. Okay, that's what they answered for the C part. As we go to the next part, D, determine the percentage of all patients that have serum HDL between 34 and 69.1. Okay, so for that, 34 and 69.1, they said. So now to understand what the question is asking, we will need to draw a picture for ourselves using the information that we had. We were having a mean at 57. And we were having a standard deviation of 11.8. And this question is saying that in the D part, determine the percentage of all patients that have serum HDL between 34 and 69.1 according to the empirical rule. So 34 and 69.1. And in the answer, they're saying, okay, 34 and 69.1 is going to be the addition of 13.5, 34, 34, and blah, blah, blah. Of all patients will have serum HDL between 34 and 69.1. How come they're reaching to that answer? What are they doing as a back calculation in this one? So I'm going to try to explain that using the information that we have. So this is the curve I have drawn. This was the mean that we calculated. And this is the standard deviation that we calculated. We were supposed to be in between 34 and 69.1. Okay. Now, I got to figure out that in the scratch work, if I am starting from the mean of 57.4 and I go below 1 standard deviation, meaning I subtract 1 standard deviation, what number do I get? So if I do the subtraction, I will get about 45.6. That's going to be somewhere here. If I go another standard deviation, which is going 2 down, so if I go 2 standard deviations down, it's going to be 33.8. And I am supposed to be in between 34 and 69. So it's not clearly giving me the empirical rule that how can I quickly convert that to 1 standard deviation down or 2 standard deviation down and all that. There is a calculator route for that available that we will do. So have your TI-84 in front and have this picture drawn. and highlight this one. If I go 2 standard deviation down, it's 33.8, which is going to be somewhere here. So it's not exactly 2 standard deviation down. It's not exactly 1 standard deviation down, but I do have this one as my lower bound and this one as my upper bound. And I'm going to go to calculator. What will be my steps of the calculator? I am going to go second button right here and distribution button right here. I'm going to press these two. Second distribution, normal CDF. This curve, this kind of bell-shaped curve is called normal curve. So I'm saying normal CDF. I'm going to click enter. When you reach here, let me know that you reach to this one. We did second distribution, and then we selected normal CDF. Now my lower bound is 34, so I'm going to fill that in. My upper bound is 69.1. I'm going to fill that in. My mean is 57.4. I'm going to fill that in. Standard deviation is 11.8. I'm going to fill that in. So I filled the lower, upper, the mean, and standard deviation. When you reached up to that far, let me know. I see Ellie is on the same page. Lou seems done. Ellie's done. Angela's done. So as we fill these values in, we go ahead to the word paste, which is highlighting now. And I'm going to say enter and enter one more time. And you will see the answer on my screen as 0.8156, which is 81%, 81.5%. That this much curve that I am supposed to find, that is about 81.5% of the area. That's what we did figure out using the calculator. Any questions? Feel free to ask.
Can you go over the steps again to get to there? I put it in the computer. I mean, I put it in my calculator, but it's not taking me past the normal CDF screen. So I entered the lower and the upper and then pushed enter.
So second distribution, normal CDF, not the PDF, CDF, and then enter. Then lower is 34, upper is 69.1, mean was 57.4, standard deviation was 11.8, and then we go down, press enter, and then we should have the, one more time, press the enter, and we should have the answer, 0.8156.
Okay, I think I know what I did. I didn't enter the other two numbers, that's why.
Okay.
Okay. And you said the, yep, 80.8156?
Yep, 0.8156, which is 81.5%.
Thank you.
So now I take us back to the slide deck where they were showing the answer 81.5%. Okay. Then I take us back to the questions. The E part is asking, determine the actual percentage of the patients that have serum HDL between 34 and 69.1. It seems very similar to the last question, but they're saying actual percentage. So they're saying how many patients would be there when the percentile is this much, like how many patients in the data are between 34 and 69.1 in the actual. And the actual means in the real. So if I go back to the data, this was the data given. So we're going to look at the numbers that are between 34 and 69.1. I'm going to make a count of those. After 34 and before 69. After 34, I have all these numbers are after 34 and before 69, the first line. In the second line, I have 62. I have 58. I have 39. And I have 55, 54. In the third line, before 69.1, I have 67, 69, 69. I have 65. I have in the third line, 60, 60, 60, 61, 62, 63, 64. So almost the whole line from here. Then I have 54, 54, 55, 56, 56, 57, 58, 59, that whole line. And the last whole line as well is between 34 and 69.1. So in this line, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 9 here, 18 values right there. And 9 here, 27, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 36, and then 9 more values right here. 36 plus 9 is 45, which they were saying and stating in this slide down here. They were saying 45 out of 54 are there, which are about 80. If we divide 45 with 54 on the calculator, we will get 0.833, which is 83.3% of the patients have a serum HDL between that. That was the last part to be answered. Let me know if any question came up to the mind or any thought occurred. Okay, now I'm going to take us down to the Z-score part. You have seen the normal curve now. Now I'm going to talk about what is Z-score and how we calculate and how we use it. So if you scroll down into your PowerPoint about by slide number 77, you will see these bullet points: determine and interpret Z-scores, interpret percentiles, and interquartile range, and check for data set for any outlier. So the first thing and the most important thing is the Z-score formula. If you take a look on my screen, there are two formulas, but they both are basically the same. Z-score is X value minus the mean divided by standard deviation. Z-score is X value minus the mean divided by standard deviation. So if somebody just wanted to write this formula as a one formula, that person will write down that Z-score, Z, is equal to how far away your value is from the mean, X minus the mean divided by standard deviation. divided by SD, standard deviation. The two formulas are written because they're using the symbol of population. For mean is mu here, and symbol of mean is X bar for the sample. That's why they're writing that. For population, standard deviation is sigma. For sample, the standard deviation is S. The Z-score is a unitless measure of the numbers, and it has mean 0 and standard deviation 1. What does that mean to us, and how would you utilize it? So I am gonna briefly take you again to the paper and some drawing with you. You now know that this type of curve is called bell-shaped curve and normal curve. In that, the mean is at the center. And we were talking about 1 standard deviation to the left, 1 standard deviation to the right, 2 standard deviation to the left, 2 standard deviation to the right, 3 standard deviation to the left, 3 to the right. They said every time when we will do the data, when we will have the value set, we're going to have various means and then different standard deviation. Is there a way to standardize all that so we can get it all together? They said, yes. Why don't you mark your mean as a 0, standard value of the mean as 0, that it's your center part. And then you go 1 standard deviation this way, 1 standard deviation this way, like you go on a number line like -1 and +1, 2 standard deviation this way, and 2 standard deviation this way. And then you go 3 standard deviation this way, and 3 standard deviation this way. That's called Z-scores that you're gonna find, okay? And they say, how about the empirical rule? They say empirical rule stays the same, that within 1 standard deviation, your data is covering 68% of the curve. Within 2 standard deviation, the curve is covering 95 percentile of the area of the curve. And then within 3 standard deviation, it's gonna be 99.7% of the curve. Okay, that's that. Now, we're gonna be using that. We're gonna be converting the given numbers to the Z-score each time. So when we convert to find the Z-score, the formula will be X minus the mean divided by SD, standard deviation. And in the PowerPoint, again stating they were writing the two formats of the same formula. If you're having a sample, you will say Z is equal to X minus X bar over the S, sample standard deviation. If you're having a population, you're gonna say X minus the mu divided by sigma. But you're gonna do the same thing in both the cases, okay? So that was little story of your Z-score. Let me know if a question comes up or a thought occurs to the mind. Taking us back to your homework 2.7, where I was. This was the question where I left you off and I said we will continue. This question says that for a unit 4 class, 4-unit class like statistics, students should spend average 12 hours studying for the class. A survey was done on 23 students and distribution of total study hours per week is bell-shaped with a mean of 13 hours and a standard deviation of 2.6 hours. Use the empirical rule to answer the following questions. Okay, so if the mean is 13 and standard deviation 2.6, they're saying 68% of the students spend between blank hours and blank hours on statistic each week. So 68%, if you remember from the curve. Now I'm going to draw the curve here again. So this is the baseline. Here goes your normal curve. And if it's 68%, that's from the mean within 1 standard deviation. Here is the mean, which is 13. And standard deviation they have given us as 2.6. SD is 2.6. So here we go. So here is 1 standard deviation to the left. Here is 1 standard deviation to the right. And that covers 68%. And what they want us to do, they want us to find this number, and they want us to find this number. That's what we're finding. 68% is given. So 13 take away 2.6 will be this number, 1 standard deviation to the left. So I'm going to say 13 minus 2.6. That's going to be my lower bound. And if I go right here, it's going to be 13 plus 2.6. That's going to be my upper bound. So that 13 plus 2.6 is 15.6. 13 take away 2.6 is going to be 13 take away 2.6 is going to be 10.4. So that is this one, the lower bound. This is the upper bound. And that will go in the blanks of this question. 10.4 and 15.6. Okay. Next one is saying 95% of the students spend between blank and blank hours. So that means now they're asking 2 standard deviations to the left and 2 standard deviations to the right. So I'm going to mark another line right here. And I'm going to mark another line right here. And now I am trying to find 2 standard deviations to the left over here and 2 standard deviation to the right over here. So now that would be, this one is going to be 13, take away 2 times the standard deviation, which is going to be, use your calculator to calculate 13. 13 take away 2 times 2.6, and that is 7.8. Then same way on this side, to find this point, we're going to have 13 plus 2 times 2.6. 13 plus 2 times 2.6, which is 18.2. 18.2. So that will go in this blank, 7.8 and 18.2. Now, if you guys can calculate the third one, which is 3 standard deviations to the left and 3 standard deviation to the right, I will verify your answer. Figure out this one, these 2 blanks, 99.7%. Take a pause and wait for your responses. Good job, Selena. 5.2 and 20.8 seems correct to me. Yep, 5.2 and 20.8 are the correct answers. 3 standard deviations to the left and 3 to the right. Anyone comes up with a question, feel free to unmute or type in the chat. Sounds good, Selena Rodriguez. Okay, about to erase. Let me know if anything before erasing. All right, so as we go further in question number 8, it says adult men have a height with a mean of 69.0, standard deviation 2.8. Find the height of a man with z-score of this to 4 decimal places. So in this case, the z-score is given to us, and we are finding the height of the man. So if you remember, the formula was z is equal to x. X stands for, like here, the height of the man. X minus, the mean is given here, 69 inches, divided by standard deviation, which is 2.8. 2.8. Z-score is given to us. Z-score is negative 2.4286. 4286 is equal to x minus 69 divided by 2.8. So our job is to find the x value in this question. And in order to find the x, the first thing that we would do is multiply both sides by 2.8 to get rid of the fraction in the denominator. So multiply by 2.8 here and multiply by 2.8 here. So that gets canceled on the right side. So this would cancel. And on the left side, if you multiply, you have 2.8 multiplied by negative 2.4286, which is negative 6.80008. There are 3 zeros and then 8. Equal to x minus 69. Last thing will be add 69 to both sides to get the value of x. You guys go ahead, add 69 and let me know what is your answer. You can type in the chat or unmute yourself. $62.199, which rounds up to 62.2. It says up to 4 decimal places. So I would say 69.1999. Then the next number is 2, so it would stop here. 62.1999. That was number 8. Number 9 is similar, not the same. It says adult men have a height with a mean of 69 inches and standard deviation of 2.8 inches. Find the z-score of a man who is 58.8 inches tall. So the mean is 69, x value is 58.8. 58.8 minus 69 divided by 2.8. Go ahead, do the calculation. You will say z-score equal to, here the x value is 58.8. Minus the mean, which is 69. Whole thing divided by standard deviation, which is 2.8. When you calculate, let me know your answer, and I will verify. When you calculate number 9, let me know your answers in the chat. $3.642857 seems correct. 3.642857. Yep, that's correct. And about to erase all the calculation. If there is any question, anything that you wanted to ask and verify, let me know. Okay, taking us down here to question 10. It says on a recent score, the class mean was 74. Standard deviation is 3.5. Calculate the z-score to 4 decimal places for a person who received a score of 83. So we are again calculating the z-score. Z-score is x minus the mean, and x is 83 here. So 83, take away the mean, which is 74, divided by 3.5. 3.5 is standard deviation. Calculate that. Let me know what you get in the chat. $2.57142 seems correct. Let's double check it here. 2.57 is correct. And the next question is asking, is it usual or unusual? So usual is considered if it's within 2 standard deviation. Anything beyond 2 standard deviation is considered not usual or unusual. Okay, so in this, we are given the 2 choices, unusual or not usual. So I will consider this unusual because it's a lot more than 2. It's 2.57. So I'm going to say unusual. Usual is up to 2 standard deviations. Taking us forward here, the height of adult men in America are normally distributed with a mean of 69.3 and standard deviation of 2.65. The height of adult women in America are also normally distributed with a mean of 64.7 and standard deviation of 2.55. If a man is 6'3", 6'3" means 75 inches. That is the X value given to us, minus the mean for the man, 69.3. 69.3 divided by the standard deviation for the man is given 2.65. And when you do the calculation, check and see if you got 2.159. $2.1509. Thank you for confirming, Veronica. Same way for the women, they're saying 5'11". In a foot, there are 12 inches. So 60 from there, 60 feet plus 11, that's 71 as X value minus the mean for the women, 64.7, 64.7 divided by standard deviation 2.55. 2.55. And when you calculate, see if you are getting 2.4706. Good job, Selena. And after comparison, we see that women's value is 2.47 for the Z-score. We are comparing just the Z-score. In the comparison, whose Z-score is higher, that's what we are telling. They're saying who is relatively taller, the 5'11" American women or 6'3" American man? What do you think? Who's taller according to Z-score? Good job, Selena Rodriguez. The women is 2.47. That's higher. So 5'11" American women is taller, because that's 2.47 above the mean, the average height of the women. About to erase and take us down to the next question. Feel free to ask any wonder or thought. Okay, this is question 12. This is saying 23 randomly selected students were asked the number of movies they watched the previous week. The results are as follows. And it says round all your answers to 4 decimal places when possible. To find the mean, you will enter your list to the calculator. If there is anything previously sitting in your calculator, you will clear that. This is your L1, 0, 1, 2, 3, 4, 5. And this is your L2, the frequency list. So go ahead and enter 0, 1, 2, 3, 4, and 5. And then in the second list, we have 2, 1, 4, 3, 8, 5. And then you go to stat again. This time choose calc and calculate your mean, your median. Let me know what you find for the mean and the median. you remind you the calculator steps, I'm going to take you here to the calculator. So as you see up on my screen, firstly in the stat, I have the first list type 0, 1, 2, 3, 4, 5, second list 2, 1, 4, 3, 8, 5. Then I go to stat, I go to calc, one variable stat, say enter, list is L1, frequency list L2, and calculate. When you calculate, you're going to have the mean, and as you scroll down, you're going to have the median as 4. So we go back here in the question. And the mean is 3.2609. The median is 4. Sample standard deviation is 1.5438. Then it's asking Q1. The first quartile is 2. The third quartile is 4. What percent of respondents watched at least one movie the previous week? So at least one movie is seen. What percent of respondents watch at least minimum one movie? More than that is possible. So it is this part of the given data. So if you take a look on these frequencies, it's 1, 4, 3, 8, and 5. If you add up, what is the total of the frequencies? Starting, how much?
23.
23 is the total. Starting from 1, leaving the first one, what is the total of rest of the frequencies? Starting from here, 1, 4, 3, 8, 5.
21.
21. And the total, all the frequencies are 23. So 21 out of 23, calculate that number on the calculator, and then multiply by 100. And let me know what number you reach at.
%91.
91%. Okay, 91.3043, something like that.
Yes.
Okay. Then the next question, let's see if you guys remember that one. We did the percentiles. This is saying 79% of all respondents watched fewer than how many movies the previous week? So 79% of all respondents watched fewer than how many movies? So what should we do in that scenario? We know the percentile is 79%. So 79 means about, you can say, think it close to 80%. And how many respondents would be there that watched about 79% of the movies? Any idea? fewer than 5. And what is the 18 that you're 18 fewer than 5? Fewer than 5 is the correct answer. Yep, 18 out of the 23. So these 18 out of a total of 23. That is the correct answer. Any wonder, thought before we move on? Taking us forward. This question is saying the following refer to the data set that's given to us. Mean, we're going to find median, the mode, and the mid-range. So you remember how to find the mean, the median, the mode. Do you remember the mid-range? I gave you the formula yesterday. Any memory of the mid-range? Yep, that was the range. If the system kicks me out, that means my battery went out. My battery is giving me signals. Min plus max divided by 2, if you remember. That's the only formula that you need to know from here.
Can you repeat that? You were cutting out.
Oh, min plus max divided by 2. The smallest number plus the largest number divided by 2. Rest you know in this one how to find mean, median, and mode, I believe. Then our last one, number 14, given a set of data that is bell-shaped, there is approximately blank percent of data within 3 standard deviation. That should be 99.7%, which we did with empirical rule. Okay, so let me know if there is any question before we depart today. Your test is open on your side, and I'm kind of talking faster because I saw my battery is giving signal, so I don't want it to cut off or anything. But our last assignment is complete. Your test is open. Test is due by tomorrow midnight. So make sure you do the empirical rule Z-score practice well and finish this homework before jumping into your test. And any questions or thoughts are welcome at this time.